Hello everyone, welcome back. Today we are going to be solving the chemistry paper for the JEE Advanced 2023. I'm going to be skipping all the inorganic questions because they are just information based, and let's try to just solve the paper analytically. So like the first one is an inorganic question. You can just check out the solutions for them, right? So the next one is basically this compound. Yeah, something like this, and since there is some nucleophilic attack, I would just draw these bonds, and yeah, something like this. So C double bond NH, and there would be PH, and then you have H3O positive, so yeah, this should be O, and then PH MgBr and H2O again, so this would just attack again, and this would be left out as OH. So when I first attempted this question, I made a mistake in this question because I thought that P is symmetrical, because this is not a chiral carbon as it has two phenyl groups attached to it, but this is an asymmetrical carbon. So yeah, they tried to trick you. So this is an asymmetrical one. So all the questions are about asymmetrical or symmetrical, right? So the other one is just pH H plus this. So obviously this is Friedel-Crafts alkylation, and you can see that this would just be acetophenone, right? Acetophenone, and then pH MgBr H2O. Very easy. So yeah, clearly you can see that this is not chiral, because this is also pH and this is also pH. So this is wrong. Q should be symmetrical, right? Yeah, okay. For the next one, we would have this, and pH CH2 minus. This is the main anion that we have nucleophilic attack right here, and this would be something like this, right? And then pH MgBr H2 again. So I'm not gonna do so much, I'll just directly write this, right? Because you would have this, and then pH MgBr, there would be a partial positive and partial negative here. This would attack here, and yeah, you would have this. Then all these steps for that, right? So this looking this, it is chiral, absolutely. So R should be asymmetrical, right? So this is a chiral compound. Okay, moving on to the next one. This is pH MgBr, then H2O again, then CrO3. So this is a mild oxidizing agent. This would become a ketone. Then you have HCN, so you would have this right here, and then H2SO4. So this is like H plus and heat, right? So positive, and then you would also have this as one second. Oh, this should be Cn, my bad. Yeah, and this would be COOH, because obviously it is H plus and heat when you have RCN, right? So that's what I did, and then you can make a double bond right here, right? So this has no asymmetrical carbon, so yeah, this is correct. And P and R are asymmetrical. Q is symmetrical right here, so this is not correct, and same with there. So C and D should be the correct one. So that's correct. Okay, styrene, we should know that it is this. Then we have B2H6, NaOH, H2O2. And you should get the feel of whenever you look at B2H6, you should know that there was something like BH3, KOH, H2O2. It's basically hydroboration oxidation, and then you would clearly have this, And then CrO3, again mild oxidizing agent, so this would become an aldehyde now. And now after Cl2, now Cl2 with red P is what? HVZ reaction, Helvollard-Zelensky, and the Cl is here. No, sorry, wait, this is Jones reagent. It's a strong oxidizing agent, so this should be wait, not Jones reagent, my bad. Yeah, so it's a strong oxidizing agent, so this should be the product, and we do have it in these two options, right? Others we'll see. Okay, so now P was this compound, something like this, right? So now we have SOCl2, so I would have this, and then NaCN, this, and then you don't even need to write it as steps. Now you have concentrated H2SO4, so this would be something like a Friedel-Crafts alkylation, and this would be attached with a 5-membered ring with this, and yes, so B should be correct for this, right? Okay, let's move on. This is again an inorganic one, you can do it yourself. Okay, what about the fifth question? So for the fifth question, well, 1 second. So for the fifth question, we can write this as HX dissociates to H plus X minus, and if you remember from ionic equilibrium, so let's say this was C0 C minus C alpha and C alpha, you would have K is C alpha square upon 1 minus alpha, and in this question you cannot neglect it, because neglect as in you cannot say that alpha is very less than 1, because if you do that, which I did while attempting the paper, you would not have this intercept P. So for that you need to keep this as that. And also if you have studied electrochemistry, you should know that alpha is just lambda m upon lambda m naught, right? So now I can just substitute this in here, and I think that's pretty much it. I don't really need to solve it, you would get this as the answer. Okay, moving on to the next one. I think I'll just leave this one. It's easy. It's a very standard one. Like if you solve some Allen or Fitzy packages, you would find so many questions like this right there. P is a phenyl alkyl ether. Just take them as one, right? Like it's an ether, so just assume an ether. Then you would have HI, so you would have phenol, and you would have RI, and then you would have NaOH, and then this, this is the R product, right? And then you would have and that's pretty much it. What do I even tell about this? Like if you're a JEE advanced aspirant and you don't know what is aspirin, then probably just rethink your life choices, whatever. So aspirin is not narcotic, of course. So it inhibits the synthesis of prostaglandin, however it's pronounced. Let's move to the next one. Again inorganic, let's leave it. The next one is way too easy. Z is just PV upon nRT. Just put that in and you would You should get the answer. This one was like way too easy. I think this should have been in a mains numerical type in mains of chemistry. Like, I don't know. 2023 was supposedly a good paper, but I don't see many good questions. Okay, this one was kind of hard to solve. There was a lot of calculation involved in this one. So basically, you just need to know that obviously that K equilibrium is the ratio of K forward and K backward. And if you want to write Kf, then you can write it as this by the Arrhenius equation. And once you take log Kf, right, you should get log A minus EA upon RT. And also I should get 2.303 right here because I took log instead of ln. So also pre-exponential factors is the same thing as the exponential factors, which is this A term right here, right? So so if you put that in, well, you should get that. And also I need to find KB, right? Log KB. So can I write KB as Kf upon K, and then from there I can say log Kf minus log K, right? And I want to find it at 250 Kelvin. So what I'm gonna do as an intermediate step, I'm gonna find log KB at 500 Kelvin, okay, which should be log Kf at 500 minus log K at 500, which is given to be 6. Now what should log Kf be? Well, I know this value should be 15 because this is given right here, and so this should be 15 log Kf. Wait, I'll just clean this up a little. We don't need this, or okay, let's just keep this here. So this should be, so log A is 15 minus 2.303 EA upon RT. This should be log Kf, and T is obviously T is yeah, it is 500 Kelvin. And once you put all these values in, well, I mean, it's a little hard to solve. I mean, I think it's easy enough. Okay, so now we have that log Kf is this, and if I want to write log for Kb, so for log Kb I would have something like 11 minus 2.303 EA upon RT, right? And if I find this, I should get that I need to solve both these equations, and then I'll get that 11 minus 1200 upon 8.314 times T is log Kb. So basically 11 minus log Kb at temperature 1 upon 11 minus log Kb at temperature 2 is equal to temperature 2 by temperature 1. And you can put this in and you should get the answer as 5. Okay, alright, let's move on to the next question. So so the first process from A to B is an adiabatic process, and from B to C it's clearly isothermal. And as soon as you see isothermal, just write delta U 0, because yeah. And so you can say from here that this is 0, so the work is equal to the heat absorbed, which is RT2 ln 10, right? And well, And if we wanna find about this, well, I can find the relation between V2 and V1 by using TV power gamma minus 1 is equal to constant. And once I do that, I should get V2 is equal to what should we get? Gamma is given to be 5 by 3, right? So yeah, this should be 10 power 3 by 2 V1. So this is the relation between V2 and V1, and then I can just plug in the values for the final expression. I mean, we can just compare this with RT2. ln 10 is RT2 ln. One second. The other part should be, yeah, so the other part should be R ln, so V3 by V2 right here. So well, V3 is just 10 times V2, right? And from there I can say that V3 is 10 power 5 by 2 times V1, and V1 is 10, so 10 power 7 by 2 is V3, and I want to find 2 log of V3, so this should be 7, right? Okay, let's move to the next question. Well, for this question, yeah, it's similar to this one. This 10th question is similar to this one. Well, for this, you should know that delta G naught is minus RT ln K equilibrium, and this given condition is important to us because 6 moles forms first, you can see 2, right? And then it forms 4. So when you find the K equilibrium, you can find the K equilibrium 1 and K equilibrium 2 from both these equations, and then you can just find delta G naught 2 minus delta G naught 1 is R T1 ln K1 minus T2 ln K2. And once you do that, well, I think it's pretty obvious by now. You know that yeah, so you can take out T2 from this equation by using this thing, and then if you compare, you should get ln 2 ln 2 minus ln 1 by 2 is ln x. So this would be 4 plus 4 times 2 ln. So yeah, x should be 8 for that, right? Okay, what about this question? Well, I think this one was an easy question. So this is very obvious that this would be NH2, NH2, NH2 and NH2. And then after acetophenone, I do not actually remember the name of this reaction, but it is very clear that what the product is, right? So this is gonna happen to all of the NC bonds. I seriously don't remember the name of the reaction. It should be somewhere in amines, in some Schiff's base something. It's okay, you don't really need to know the name of the reaction for this. I mean, now you need to find sp2 hybridized carbons. So remember not to count the nitrogen. So 1 and then 6 here. So 7 times 4, 28. Okay, inorganic. Let's just leave it. Again inorganic. Okay, let's just do one. We can do one, right? So this is Fe2 plus, and for Fe2 plus we can write the configuration as Ar3d6. So Also, this is a weak field ligand, so we can clearly see that this would not happen, and clearly this should exist as T2G 4 and EG 2. So S matches with 1, so we have one out of these two options. Okay, so P3Q2, so I need to check R. So R can be either this or this. So FeCl4 minus, note that this is either it has coordination number 4 in this one, so this is Fe3 plus, and Fe3 plus is Ar3D5. Again, this being a weak field ligand, this is a strong field ligand, but that won't help because we don't need about Q. So this is the configuration, and yeah, nothing would happen. It would just form sp3, right? This is an sp3 complex, so it should be E2T23, so R should match with 4, so D option I think should be correct. Yes. Okay, this looks like a good question. Yeah, we've almost solved the whole paper, and it's not even been 10 minutes yet. That's nice. Okay, so for this question, this one was kind of a trick part. So basically, you would have 1 bromo, 2 ethyl pentane, and it's saying that SN2 would happen with aqueous NaOH, which is not wrong, but this won't cause inversion of configuration, because note that this is not a chiral carbon. So if anybody did that mistake, like, you need to check a little, because advanced is gonna do that. Alright, so this should be retention of configuration. So these two options are already eliminated. About Q, well, we can see that, oh, actually I forgot, I am compiling these videos, so it's not really 10 minutes, it's a little bit more than that. Whatever, I hope you like the video. 2 bromo pentane, a single enantiomer, and aqueous NaOH, again SN2, and again yeah, so this should have the inversion of configuration. Obviously it won't have mixture of structural isomers, so already B should be the correct answer. But even if you ignore that, others, R is 3 in both and S is 5 in both. But okay, let's see it. So we have hexane, 3 bromo, and 3 methyl, and we have SN1, so you would have a carbocation right here. So what is the option? Yeah, so it should be a mixture of enantiomers. And about the last one, SN1, then again you would have a mixture of diastereomers. So nothing really special in this one. This was very logical, and this is information based, and you should just know the Gatterman reaction, which is this one, right? So Q is 2, and this is correct straight away. So yeah, I mean, wasn't that hard? Well, you can see itard is this one, to produce toluene. For Q, I wrote Gatterman reaction. For Gatterman-Koch reaction, well, you would have this thing. Acetophenone is this, and then you would just have this, right? For Rosenmund, you can have, right? So yeah, I think yeah, we've solved the whole paper, and let's see again how it went. Yeah, so I mean, this one was very simple. So the good thing about this one paper, I don't know about paper two, but in paper one, you could easily say that. I mean, there's nothing that puts you in two minds. You can be sure about your answer. So yeah, and physical was also easy, and I took one of inorganic too. This one was a little bit hard to explain for me too. I didn't know how really to explain this, because it's a lot of calculation, and others, yeah, you can see that. This one was a little bit prone to uh, doing negative in this. Others were simple, like this one was very simple. Should have been done. I think if you've prepared well in your coaching papers and all that, you would really easily be able to do this paper. You can even do all of them. Like, if I would be personally giving the paper, I might leave one or two questions of inorganic if I am in two minds, obviously, because I don't not want to get negative marks. But otherwise, it's not that hard. So I hope you liked this session, and I hope I was able to make it look like an easy paper. And keep liking if you do like this, all this, right? So I could even come up with a few questions of physics of this paper or of anyone. I might even upload for Alan's core papers. So yeah, thanks a lot for watching.